Product rule. So if I have multiplication of two functions, what is their derivative? Well, f of x plus h times g of x plus h minus f of x times g of x all over h. So that is our definition for the derivative. Then what I'm going to do is, what we are doing in the next step is that there is an expression, just like I can multiply by 1, I can add something and then subtract it back so that it cancels out, and I would get the same thing. Like I could, on top here, I could put a plus 5 minus 5, and it wouldn't change the value, right? And so that's what I'm going to do. There we go. All right, so I'm going to subtract this expression, f of x plus h times g of x, and then I'm going to add it back, the f of x plus h times g of x. And then we have minus f of x times g of x. The reason I can do that is because now I can group these together, and I can group these together and see what can come out of each. Out of the first group, I can take an f of x plus h out. Out of the second group, I can take a g of x out. So so here's the first group. I'm taking an f of x plus h out, and what I'm left with is g of x plus h minus g of x all over h. Over here, I can take a g of x out of the second group, and then I'm left with f of x plus h minus f of x all over h. Now this part g of x plus h minus g of x all over h, that is the definition of the derivative of g. That's g prime of x. Over here, this thing is the definition of the derivative of f. F of x plus h, if I plug in 0, is just going to be f of x. So we have f of x times g prime of x plus g of x times f prime of x. This is the product rule. And that's how you would prove the product rule. The way that we're going to say the product rule is that it's going to be first times derivative of the second plus the second times derivative of the first. So if I've got two different functions that are multiplied together, that's going to be the derivative. First times derivative of the second plus second times derivative of the first. That is our product rule. Now we start examples. I'm writing it down in the notes. All right. Before we talk about the product rule, we could do this a different way. You're nodding your head. What is the other way?
I was going to, maybe the shortcut method. I was asking if that's the word.
Yeah. So how would you do it then? I could rewrite this so that I could use the methods we were talking about last time, which is I could distribute this, right? And once I distribute it, no more multiplying, no more product rule. So 3x times 5 is 15x. 3x times 4x is 12x squared. Now I'm distributing it a minus 2x squared. So minus 2x times 5 is going to be minus 10x squared. Negative 2x squared times a positive 4x is going to be a minus 8x squared. Or sorry, 8x cubed, because we have an x squared times x. Positive 12x squared minus 10x squared, and then minus 8x cubed. All right, we'll put a pin in that. We can take the derivative of that, but before that, let's see what the product rule looks like. So here are the two things that we're multiplying together. Again, first times derivative of the second plus second times derivative of the first. First, so we're just going to rewrite 3x minus 2x squared times derivative of the second. So I want derivative of 5 plus 4x. Derivative of 5 is 0. Plus derivative of 4x is 4. Plus the second, which is 5 plus 4x. Times derivative of the first. Derivative of 3x is 3. Minus derivative of 2x squared is going to be 4x. So we're going to wind up having to do some distributing anyway. 4 times 3x is going to be 12x. This is going to be minus 8x squared. This is going to be 5 times 3 is 15. 5 times negative 4x is going to be negative 20x. 4x times 3 is 12x. Almost made it. Minus 16x squared. Simplify that. We have a negative 8x squared minus 16x squared is a negative 24x squared. Twelve and 12 is 24 minus 20 is 4. Plus 15. Oh, let's see what we get over here. Derivative of 15x is 15. Derivative of 2x squared, 4x. Derivative of 8x cubed, 3 times 8 is 24. X squared, oh my goodness, it's the same answer. So which way is easier? Well, that's up to you, and it depends on the problem in this case. So this is kind of the first look at, there's multiple ways to get our derivative and to work out our derivative. Sometimes you're going to have multiple ways of being able to think about how this derivative looks. But let's do some problems where we clearly need to use the product rule, where we're not going to be able to solve it without the product rule. Find the derivatives of the following functions. G of x equals x times cosine of x. So we have two different functions multiplied together. We would not have a rule for this without the product rule. So we have x, and we have cosine of x. Those are our two functions we're multiplying together. So G prime is first times derivative of the second, derivative of cosine.
Sine.
Huh?
I said sine, is that right?
Negative sine.
Wait, how did, oh, is that from notes?
Yes, it is. Derivative of cosine is negative sine plus second times the derivative of the first. Derivative of x, bring the exponent of 1 out in front, times x to the 0. 1. Derivative of x is 1. It's y equals x. The slope of y equals x is 1. Equals, so we have cosine of x minus x sine of x. If we wanted to simplify it. Next. Got two different things I need to take the derivative of.
Wait, that's your final answer?
Yep. We'll start with 2x sine cosine of x. That's a product rule. We have to do it with a product rule. This first one is a product rule. First, which is 2x, times derivative of the second. Derivative of cosine is negative sine. Plus second, which is cosine of x, times derivative of the first. Derivative of 2x is 2. Minus, and then we have 2 sine of x. This is not a product rule. We don't need the product rule for this one. Because if we just have a constant out in front, then we can keep the constant out in front and then have the derivative. So 2 times derivative of sine of x is cosine of x. So remember, derivative of sine is cosine, derivative of cosine is negative sine. So if we wanted to simplify this, this can actually be simplified a little bit. Because I have a cosine of x times 2, and then minus 2 cosine of x. So these can actually cancel. And all we're left with is negative 2x sine of x. So we talked about when we multiply two functions. This is going to be dividing two functions. So I have, if I have f of x divided by g of x, so g of x is the bottom function. We have the bottom function times the derivative of the top, and then we're subtracting the top function times the derivative of the bottom. So it's kind of similar to the product rule on top, but now we have subtraction over that bottom function squared. And so the way that I'm going to say it for you to remember it is going to be low d high minus high d low over the square of what's below. That's going to be your memory trick for remembering this quotient rule. Low d high minus high d low over the square of what's below. So low, bottom function here, d high, derivative of the top function, minus high, the top function, d low, derivative of the bottom, over the square of what's below. That's to help you remember the quotient rule in the order that it goes in. So let's look at an example here. let's see. So we have the function on top. I'll put in green. The function on bottom, I'll put in blue. Low d high minus high d low over the square of what's below. All right. Low. So we're just going to write out the function on the bottom. I've got an x squared minus 1. Or sorry, an x squared plus 1 on the bottom. So that is a low. D high, derivative of 5x minus 2. Well, derivative of 5x minus 2 is just 5. Minus high, the top function, I'm just going to write 5x minus 2. D low, derivative of x squared plus 1. Well, derivative of x squared is just 2x. Plus derivative of 1 is 0. Over the square of what's below. So that bottom function is squared. Now again, I can simplify this. X squared plus 1 times 5, so I've got a 5x squared plus 5 minus 2x times 5x is 10x squared minus 2 times 2x is 4x most of the time it's not worth squaring out the stuff on the bottom. Equals, I've got a 5x squared minus 10x squared. That's going to be a negative 5x squared. This is a minus a negative 4x, so this is going to become a plus 5 over x squared plus 1 squared. All right, I've got a fraction and a fraction. How do we deal with this? Got two different ways we can deal with it. One I think is easier. Just like before, we have multiple different ways we can do this. But the rule of thumb for simplifying is if you can simplify now or later, then now is usually better. Now is usually going to be easier. Simplify now or later, now is usually better. So if I want to simplify this, then that means I got a fraction and a fraction. I don't want to deal with that when I go to take the derivative. So I'm going to get rid of the fraction and a fraction by multiplying top and bottom by
1.
no. X. So I have on top x times 3 minus 1 over x. Well, x times 3 is going to be 3x minus 1. On the bottom, now I have x times x is x squared plus 5 times x. So now instead of the fraction and a fraction having to deal with it, if you did want to deal with the fraction and a fraction, then I would treat this as x to the negative first and use a power rule instead of having a quotient rule wrapped inside a quotient rule, which you can also do it that way. But again, now is usually better for simplifying. Derivative. Here we go. Low d high, derivative of 3x minus 1 is 3. Derivative of 3x is 3 minus derivative of 1 is 0. Minus high 3x minus 1. D low, derivative of x squared. We're taking derivative of the bottom here. So derivative of x squared here is 2x. Derivative of 5x is 5. Over the square of what's below. Here we go. Let's do some distributing. So again, to recap, we had low, d high, minus high, d low, over the square of what's below. Now we're distributing. Distribute the 3. So I have a 3x squared plus 3 times 5x is 15x. Minus, we're going to subtract this whole thing that gets distributed out. 3x times 2x is 6x squared. We've got plus 15x minus 2x minus 5. All over x squared plus 5x squared. Let's see. I've got a 3x squared here minus a 6x squared, so that's a negative 3x squared. I've got a 15x minus a 15x minus a negative 2x, so that's going to be plus 2x. I've got a minus a negative 5 plus 5 over x squared plus 5x squared. So the quotient rules can get a bit messy, but that's the idea. Low d high minus high d low with the square of what's below. Product rule, first times derivative of the second plus second times derivative of the first.